Assalamualaikum everyone, my name is Nur Shamimi and today we're going to talk about volumetric analysis in water treatment. So before we go to the water treatment, we should know the meaning first. So the meaning is general term for method in quantitative chemical analysis, in which the amount of substance is determined by the measurement of the volume that the substance occupies. So it commonly used to determine the unknown concentration of a known reactant. Basically, it is often referred to titration. Basically, we have four principles of volumetric analysis. First, based on titration between two solutions, and use standard solution titrant and unknown solution that is called analyte. Second, titrant is added from burette until the reaction is complete. Third, reactions will follow the stoichiometric relationship. And lastly, endpoint is detected and using the indicator provided.
So next we will continue why is the water treatment really important, especially in Malaysia. So the first one is can remove contamination, because water treatment can remove harmful chemical pollutants. It extract toxic matter like leads. So it protects humans' health from dangerous toxic. So the second one is eliminate harmful microorganisms, because the process will kill the dangerous bacteria and virus. It eliminates invisible waterborne parasite. They stop the spread of deadly disease. So the third one is can reduce water hardness, because it removes excess calcium and magnesium mineral. They stop scale build in your pipes. It also extend household and appliance lifespans. So the last one is can ensure safe of drinking water, because the system guarantees clean water drink. It ensure the water in order free. So it secure reliable life health.
Next, I'm going to explain to you about how the volumetric analysis occurs in water treatment. So the procedure are following. First, collect water sample. So we collect water sample from the river and add it into a clean beaker or conical flask. Second, we need to use indicator. We need to use indicator as a few drops only for the suitable indicator to the water sample. Third, we should prepare the burette, that is called as a titrant. So we need to fill the burette with standard solution titrant of known concentration. Fourth, start titration. Add the titrant from the burette slowly into the water sample. Remember, do not use the burette faster because it can change your data. Fifth, we need to swirl the flask. Swirl the flask continuously to ensure complete mixing and preparation. And sixth, reach the end point. Saturation is complete when the indicator shows a permanent color change. As example, my solution before titrant is white. So after the titration, we have a pink that is permanent. So that is show you the titration is complete. Seventh, we need to record the volume. Record the final burette reading and calculate the volume of titrant used. Okay, so we should record volume by meniscus of eye level and should avoid the parallax error because it can reach your data. And lastly, we need to calculate the concentration. Okay, we need to calculate the concentration based on what we recorded as a data to determine the concentration of the substance in water sample.
So next, we're moving to the process of a water treatment. This process have a 5 stage. So the first one is coagulation and focalization. Chemical like aluminium sulfates are added to the water, causing tiny suspended dirt particles to clump together into large, heavy, and clustered colored flock. So the second one is sedimentation. The water sits calmly in large tanks. Gravity forces the heavier flock to the settle on the bottom, which can remove easily. The third one is filtration. So the clear water on top of a passing through layer of sand, gravel, and charcoal to filter out any remaining microscopic. Next, we have disinfection. So the chlorines or ozone is added to kill any remain of bacteria, virus, and parasite, ensuring a water is completely safe for consumption. So the last one is pH and fluoride adjustment. Lime is added to the balance of pH, so the water is corrosive. The fluoride is obviously added to promote dental health. So next, we're moving to the application of the water treatment. So we have 3 applications that I'm staged here. The first one is municipal drinking water supply. So pure raw water when water or groundwater to meet safely standard for human consumption. So the second one in industry processed water, conditioned water to prevent scaling, rush, and rolling inside the machine. Industry like power generation or food and microelectronic really heavy on ultra pure water to prevent product defect and system downtime. The last one is domestic and commercial point of use. We utilize reverse osmosis or RO filter active carbon block and home water softener. There's individual system improve taste, remove toxic heavy metal, and also tackle local hard water tissue.
Volumetric analysis offers several advantages in water treatment. It is a highly accurate and precise analytical method because it measures the exact volume of a standard solution required to react completely with the analyte. The technique is also cost-effective since it only requires basic laboratory equipment such as burettes, pipettes, and standard solutions, making it affordable for routine analysis. In addition, the procedure is simple and easy to perform with proper laboratory training, allowing technicians to obtain reliable results efficiently. Volumetric analysis is also relatively fast, making it suitable for routine monitoring of water quality. Furthermore, it is widely used to determine important water quality parameters such as water hardness, chloride concentration, and alkalinity, which are essential for ensuring that treated water is safe for domestic and industrial use. Despite its advantages, volumetric analysis also has several limitations. The accuracy of the results depends greatly on the skill and experience of the operator, as mistakes in reading the burette or preparing the standard solution can lead to significant errors. The method is also sensitive to human error, particularly during endpoint determination, where slight color changes may be interpreted differently by different individuals. Moreover, volumetric analysis is only suitable for analyzing certain chemical substances and cannot effectively detect trace contaminants or complex organic compounds that require advanced instrumental techniques. Although each titration is relatively quick, analyzing a large number of water samples manually can become time-consuming. Therefore, while volumetric analysis remains useful, it is not always the most efficient method for every type of water quality analysis. In conclusion, volumetric analysis is an important analytical technique in water treatment because it provides accurate, reliable, and cost-effective measurements of essential water quality parameters. Its simplicity and efficiency make it suitable for routine laboratory testing, particularly for analyzing hardness, alkalinity, and chloride concentration. Although the method has some limitations, such as its dependence on operator skills and its inability to analyze certain contaminants, it remains one of the most widely used techniques in water treatment laboratories. Overall, volumetric analysis plays a significant role in ensuring that water meets the required quality standards and is safe for human consumption and environmental protection.